psych for its principal components function. I'm also going to check the dependencies because I know I'm going to need this one right here, GPA rotation. So I'm going to come back and load that one separately. And now I'm going to load some data. What I've done is I've downloaded a data set, a public data set from online that contains information from the Big 5 personality inventory. I'll show you some information about this data set. If you go to the codebook.txt file, it describes how the data was collected and the 50 variables, the outcome variables in it, that describe 5 personality factors writ large. They're extroversion, neuroticism, agreeableness, conscientiousness, openness to experience. And we have 10 items for each of these, so there's 50 items total. You can see what the actual items here, and they're rated on a 1 to 5 scale. And we also have some demographic variables. Now I've simplified the data set a little bit by removing about 6% of cases that had missing values. But we still have nearly 19,000 cases, so we're good to go for principal components. Let me go back to R. And the first thing I'm going to do is I'm going to read the data file from a CSV file. Now I put it on my desktop and I'm going to use the read.csv function and save it into an object I'm calling B5 for Big 5. Let's take a look at the column names here, and when I zoom in on that, you can see these are the 50 column names that we had from the codebook. I'll go back now. And as a very quick check on the data, let's get box plots of all of the variables. I'm just going to run it on the entire data frame all at once right here. Now it makes a very busy plot, but let's zoom in on that. And really what you can see is the variables all range from 1 to 5. And the medians bounce around a little bit between 2, 3, and 4, but that's fine. Now to do the actual principal component analysis, there's a couple of built-in functions in R. You can use prcomp or princomp. They both have their advantages, but I personally prefer to do PCA with the principal function from the psych package because of some of the extra information and graphics that it gives. Now I'm going to do this a few ways. First I'm going to do a very basic one where I'm going to specify 5 factors. I'm doing that because I know that there's supposed to be 5 factors here. I'm going to put that into PC for principal component 0 sort of as a baseline here with no rotation. Where I use principal, I specify the data, which is B5, and the number of factors, which is 5. I do that, and then I can check the results by simply calling on that object. And I'll make this bigger here. And it's got a fair amount of printout here. So it gives the call here. And these are the standardized loadings. What we have here are the 5 components. Now, interestingly, they're not listed in order. They go PC 1, 2, 5, 3, and 4. H squared is a measure of communality, and that is how much information these variables share with each other. The U squared there is uniqueness. And the last one is a measure of complexity. We don't need to worry about that one. But these numbers here can be read like correlation coefficients. They go from 0 to 1. They can be positive or negative. And bigger absolute values indicate that that variable contributes more to that particular component. Not surprisingly, these first 10 variables, which all have to do with extroversion, I'm going to highlight those, all have strong absolute associations with the first principal component. And then you see that it drops off a lot after that. And then it moves over to the second column where we have some strong values again, and so on. Going down in the output, you can also see how much of the variance in the total data set each one of these components accounts for. The first one accounts for 5.5 units of variance. And that's approximately 11% of the variance in the total data set. So that's a good amount. And then these 5 components between themselves account for a cumulative variance of about 46%. And now let's go back to the code for just a moment. I'm going to do a small difference here. I'm going to do what's called a rotation, where I'm going to actually take the information, and then by rotating the information a little bit, I go from principal components to rotated components, which can sometimes be easier to interpret. So I'm going to run that now, where I save it as PC1, and I specify rotate oblimin. That's an oblique rotation that allows for the components to be correlated. I actually think that's a useful thing, so I'm going to do that. And we'll check the results on that one. I'll zoom in on that again. And the important thing here is that they're really similar to the results we had last time because there's a very strong component structure in this data, but the numbers are slightly different and there's a slightly bigger fall off as it goes to the next item. So we have a very clean structure here. Also, because this is an oblique rotation and it allows the components to be correlated with each other, we have the correlations between each of them right here. And the final thing we want to look at here is a plot that we can get from the principal function in the psych package. It's just called plot on PC1, and we get a very colorful plot. I'll zoom in on that. And what it's showing here is not cases, but how variables are associated with each of the components. We have 5 different components, so we have 1, 2, 5, 3, and 4, and then we have groups of variables that load on each of these components. And what this is doing is it's showing 5 different kinds of markers: red circles, black circles, blue circles, and then we have gray squares and black diamonds. And those indicate the 5 groups. And you can see how, for instance, over on the left under PC1, you've got this really strong separation of the black circles. They're going way off to the side. And the blue ones are going up and down on the top on PC2. In fact, you go to the second column, you see them pushed out to the side, and then the red circles out to the side, and then the gray squares out to the side. And so you see how each of these components is able to separate some of the variables from the others, which is the overall goal of principal components analysis. And so you see that in R, this is very easy to do using the principal function in the psych package, and it's nice to get both a numerical output and a graphical output as a way of seeing how you can safely and reasonably reduce some of the dimensionality in your data to make things easier to deal with and have more reliable and more interpretable results.